Hello everyone. We defined a couple of properties in the capillary pressure, and we introduced you to a couple of concepts. Now we want to talk about displacement pressure. So in order to define that, consider that you have a tube, and in this tube you have completely saturated the tube with the gas. So as we mentioned previously, gas is always the non-wetting phase. Now you introduce some water at the entrance at one end of this pore, and you put the water here. So what happens? Gas is the non-wetting phase and water is the wetting phase, right? So in order for water to displace the gas, you don't need any force, because the adhesion tension of the water tries to wet the surface, and as time passes it will displace the gas, and the adhesion tension will force the gas out of the pore. So this is called a spontaneous inhibition. It means that you don't need really to push the water into the pore in order to displace the gas, because the water itself likes the surface of the tube and it will displace the gas by itself. Okay, now consider a case that you have, this is called spontaneous inhibition, right? So before continuing, I'm going to ask you these two questions. How far does the water go? So if you have this horizontal pore and then you introduce the water at one end, what happens? How much of the gas will be displaced? The answer is the water will displace all the gas until it filled the pore, because there is nothing to resist the water for the water to stop, right? Now, what if you had a pore like this and then you had gas here and then you introduce the water at one end? Will it go all the way top and displace all the gas? The answer is no, right? Because it will wet the surface, right? Try to rise inside this tube, but it will stop at some point. The reason is what? There is a gravitational force of water being applied downward, which basically is competing with the adhesion tension of the water, right? So this is where these two forces balance. Okay, so if you have a rock or tube and it's vertical, you put the water at the bottom, the water will go up until these two forces are balanced with each other. Alright, now consider this case that you have basically water inside the pore, and then in this pore you want to displace the water, and water is the wetting phase, and you introduce some oil here. Now, oil is the non-wetting phase. Does oil like the surface? Nope. Water likes the surface more than the oil, right? So the water automatically, oil cannot displace the water out of the pore, right? You need some force, you need some push to the oil in order to be able to displace the water, because water is the wetting phase. Okay, so in this case it's called forced inhibition, and you want to displace the wetting phase by pushing the oil into the water. How much force do you need? Well, that's the question that we have, right? So how much you want to push is called displacement pressure. Displacement pressure. So the amount of force that you need in order to be able to displace the wetting phase from the pore or from a tube by pushing the non-wetting phase into the pore or the tube is called displacement pressure. Okay, so that's the definition of displacement pressure. It's mentioned here. It's sometimes called displacement force as well. Force is just basically force, pressure is pressure, different type of properties, but doesn't matter. This is the definition of displacement pressure or displacement force. All right, now consider this case, right? You have a couple of pores and then you want to push oil. So assume that initially all these pores are filled with oil. They are different sizes, and the oil will come here, right? It will displace the water, right? And then look at these pores. What do you see? We have more water here, less water here, no water here. What is the reason? We forced the oil into the pore, right? And it could displace all the water from this larger pore. What is the reason? The reason is that it needs less, it has less capillary pressure, so it needs less displacement pressure, so you can push the water easier out of this pore because it has a higher radius. Now for this pore, the radius is smaller, the capillary pressure is higher, you need more displacement pressure. So you push the oil, you can displace some of the water, but you cannot displace everything, right? So partially you will displace the water, and then you still have some water here, right? Now this pore, the force that you applied, it was not enough even to displace a small amount of that water. So you cannot displace the water from this pore at all because of high capillary pressure or high displacement pressure that you need in order to be able to push the water out of this pore. Okay, so this is really important, and we'll talk about it. We will do some examples to tell you how do we calculate or how do we measure this displacement pressure and how would it affect the saturation in next videos.